We shall discuss about channel coding. Channel coding is also known as error coding. So physically, if we look at it, that means on one side we have given information, say X, and then in between we have a channel here. A channel can be a collection of devices or means or algorithms to carry certain information from the input X to the output Y. So if we recall that block diagram that we had drawn in case of for data communication, between channel coding and decoding, we have the analog front end. And also there are various kind of network elements which will impart information to the data coming as an input to this channel coding stage. So, however, the channel coder will treat them as an intermediate, as a black box, because whatever information is available at the input channel coding and to the output channel coding stage, so that will be treated as the valid. So that means I have a channel coding hardware or software, which is basically putting a binary stream of data in a particular fashion and then launched for transmission. And through the transmission, there could be several things happens. There would be many other data that will be added to this particular data to enable that the receiver or the receiving side receive it in a particular manner. So all those address, etc., all those networking functions will be done in between. And then we have analog front end. Basically, there will be modulation, and there will be demodulation at the reception site. So those analog modulation, demodulation also introduce certain amount of error, as well as there could be error due to certain malfunction of various digital devices as well. However, the whole thing is treated as a black box. Just like when we were discussing discussing about source coding, we have taken information as a set of symbols. So those symbols are available by the object coder at the sending end, which is preparing the data for this channel coding stage. And then the receiver side, the object decoder will get out of those symbols. So therefore here, basically we have an X as the input. Input symbols or input codes. And Y as the output. Symbols or codes. Because in between there are many operations, both analog and digital, so therefore size of Y may vary with respect to the size of X. So this is the general framework. Now, because there is noise, there is a finite probability of error. So therefore, here initially we will take this model as say X as a set of symbols and Y is another set of symbol. Now this generally when we study the property of the channel, there are various properties. When we do channel coding, we take the properties of the channel kind of independent of the symbols. So that means, and also as such, the symbols x0, x1, they are independent of each other. We call them as random variables. Though we have not discussed that much of, we have not discussed at all in this course of random variables. Random variables are basically the generate a value which is not dependent on another or other entities in the set. So, and they are also discrete. These are discrete and random. However, because we are studying a finite set of symbols, there is a occurrence of probability of these particular values, that is x0, x1 with respect to the total number of occurrences. So therefore, there is a probability of occurrence that we have used for source coding. So when we were discussing about the probability of occurrence of these discrete and randomly occurring symbols, so then of course we have not considered to generate any other symbol. So however, the purpose of channel coding is to study the behavior of this channel, that what is the probability that x0 can be interpreted as y0, or x0 will result into an event of y0 at the output, or and x0 may result into an event of y1, and x0 may result into an event of yk minus 1. So there would be all finite probabilities that this may happen. However, the purpose is that of channel coding is such that x0 will most likely be uh, generating an event y0 at the detector site or the receiver site. So that is the purpose of channel coding. So because here in this block of channel coding, The main concern is to transmit the symbols reliably. However, due to the error introduced in the transmission path, through digital and analog equipments, there is a finite probability of resulting any yk from any xj. So k varies, so, uh, both are the input and output and input variables. So therefore, there is a finite transition probability from any input symbol xj to any output symbol yk. So this is popularly known as transition probability. So the transition probability P giving yk from xj can be written like the from set of yk
So capital X and capital Y are the random variables, right?
yes, small xk for all j and k.
That will be X J, right? Y equal to YK, X equal to XJ.
jk
Like the second statement, so like P
for
of
all j and all k. Oh, x equal to, yeah, j. So therefore, we can also say that because there is a finite probability, so it may happen that the transition from xj to yj can happen in an xj to yk can happen in a error-free manner. So in that case, the probability that is yk xj corresponding to an input of xj will be equal to 1, and if it is other way, then it will be equal to 0. So this both can happen. So that means if I transmit 1, it is detected at 0 all the time, it may happen. Or if I transmit 1, it is detected as 1 all the time, that may happen. So now this there is another assumption that is made, is that this channel is memoryless. So that means all these occurrence of these symbols both in x and y does not depend on the previous symbols. That is, the occurrence of xj does not depend on any of the other symbols in x or in any of the other symbols in y. So now if we combine it, combined together, this it can be represented as a channel matrix. Which is a collection of the transition probabilities. So the channel matrix P would be equal to y0 x0 y1 x1 yk minus 1 x0 p y0.
So the second entry would be py1 given x0, right?
Yes, py0 x1. So this column is for y0. Similarly, this column is for y1. So this matrix is known as the channel matrix, which is a collection of the transition probabilities. This is also uh, known as the probability of error or conditional probability of error. Often that's why this channel coding is referred as error coding. So in popular terminology, because basically we will see later that a number of bits or various kind of manipulation of the bits are done to avoid the errors following certain rules.
अरे मेरे से इवेंट हुआ ना मेरे पास उसकी क्या अंदर भी बुलाएगा अंदर
Yes, and
अभी तो अंदर अभी तो आया मैं
so also if we from our previous observation that there is a finite probability of from x0 to y0, finite probability from x0 to y1, and subsequently up to say x0 to yk minus 1. However, if we sum all these probabilities, so that probabilities of course will be equal to 1. So similarly for this side also we have k equal to 0 to k minus 1. So that will also give equal to 1 for all j.
The sum of conditional probabilities, how will it be once? Doesn't it have to be multiplied by probability of x0 also?
Probability of x0.
So if we add all the probabilities, it is 1, but this is conditional probability, right?
For any xj, say we can write for any xj, if we compute the probability from xj to any of the y, so there would be a finite probability, but from the same symbol, the other probabilities have to share the occurrences. Suppose there are, we have measured this output corresponding to xj 10 number of times. Okay. Then y0 happened, suppose 8 number of times, y1 happened 1 time, and say y8 happens 1 times. Then the rest of the y's has to be 0. Because we have taken only 8 occurrences out of this x0. So therefore, the sum of these occurrences, that is corresponding to a particular symbol xj. So if I take j equal to 0, so therefore the probabilities of y0 x0, p y1 x0, p yk1 up to p yk minus x0, if we sum, will be equal to 1. Similarly, if we sum p y0 corresponding to x1, p y1 x1, like that up to p yk minus 1 x1, that is equal to also be 1. Similarly, for all y's, we will have this rule followed. So that means for xj minus 1 p y0, so that will also follow the same rule. So for any j, the probabilities of having the set of yks will be equal to 1. For an input xj, for any input xj. So now we will introduce binary symmetric channel. So binary symmetric channel is basically for the binary system where we have only two symbols, 0 and 1. Okay, so therefore we will have the input side 0 and 1, that is uh, there are only two symbols in the input side. Similarly, at the output side we have two symbols, y0 and y1, so they could be, they are respectively 0 and 1. Now suppose we define the probability, transition probability in terms of error that we define as a P. We could define the other thing also P. Okay, but because mainly we are concerned about the error probability, so that's why this we define, and conventionally this is defined as P. Okay, so therefore x0 to y0, so that means that will be 1 minus P. Okay, because from x0 it could be either go to, as y0, detected as y0 at the output, or y1 as the output. Okay, similarly if I take this x1, that also same thing. So we take P as the error probability, that is 1 to 0, and 1 minus P is 1 to 1. So this is binary symmetric channel because it is also the probability is symmetric. So that means both has having the P probability. Okay, so then we call it also symmetric. So P is given by the error probability that a bit of either 0 or 1 detected as 1 or 0 respectively. So in binary, that is digital transmission, therefore this concept of binary symmetric channel is important. Now, once we define this transition probabilities and the channel, so next is that how we represent the information flow in the channels. Now, in case of source coding, we have a discrete memoryless source, and our main concern is to keep the source information intact. So in other way, our main purpose is to ensure negligible redundancy in source coding. And therefore, if we interpret in terms of, we was always checking with some entropy, okay, that how efficient our source coding was. So that means that in terms of entropy, if I interpret the source coding, then we can say that if a source with entropy HM is coded with HM bits per symbol, it has zero redundancy. So that would be like optimum source coding. Similarly, for noisy channels, also similar similar concept can be defined, and that comes through the definition of mutual information. So we can say that in terms of entropy, if we interpret the channel in terms of information and entropy, the concept of mutual information comes into picture. Because of the finite transition probabilities of all output symbol from a input symbol. So that means, therefore, the information carried by Y0, Y, or any of these symbol Y0 is a collection of information from the set of inputs. So that's why the mutual information concept is coming here. In case of source coding, we did not have this scenario where this transition probability is occurring. So basically, our purpose was to check the information content and the corresponding entropy. But here, because the transition probability is involved, so therefore we have a mutual information.
Could you explain what is mutual information? I could understand.
Yeah, we shall come into it. Suppose now we will define the entropy, conditional entropy. So in this case, similarly, unlike entropy in source coding, conditional entropy comes into picture. So the conditional entropy, say, of X corresponding to the set of Y, that is the output, would be, say, if we sum all the transitional probabilities or conditional probability, Xj, Yk, and log of 1 by P. That is our definition of entropy, was P log 1 by P. So here this P is replaced. Probability of occurrence in case of source code, it was just probability of occurrence of a symbol. Now here the probability of occurrence, that means of occurrence of Xj corresponding to Yk. So suppose I have detected Yk, and what is the probability that that will be interpreted as Xj? So that becomes the information content of one symbol with respect to the other symbols. So this way, now if we take the mean of this, mean of H X Y, sorry, capital Y Yk, then we have on an average sense Y with respect to, we detect X with respect after detecting Y. K equal to 0 to K minus 1. Over Y. Y equal to Yk. P of yk. So k equal to 0 to k minus 1, j equal to 0 to j minus 1. We replace this h. P of xj yk, P of yk log 2 1 by P xj yk. So which can be written as k equal to 0 to k minus 1, j equal to 0 to j minus 1, capital J minus 1, P of xj comma yk log 1 by P xj yk. So where this P xj comma yk is representing P xj conditional probability of xj with respect to yk multiplied by the probability of yk. So this one is known as the conditional entropy. So this basically means in the output symbols, what is the uncertainty present for detecting various input symbols. So given when we detect any output, so in that output, what's the possibility that that is misinterpreted as any the input symbols x0, x1, etc. The mutual information I x y with respect to y is given hx minus h x conditioned with y. So that means the entropy of x which is shared with y, so that is known as the mutual information. For symmetrical channel, of course, xy semicolon.
Sir, is this in the Haken book, sir?
Yes,
Sir, is this in the Haken,
is it?
in the Simon Haken book, sir?
Ixy equal to hx minus hx conditioned with y.
No, sir, this topic, sir, like, where can we read it, sir? Like,
Oh, this is in both the books it is there. In Haken's book also it is there. This is like chapter 2 itself it is there.
chapter 2, sir, is like maths topic, sir. Like,
Yes. Now, in terms of this, the channel capacity is defined in terms of this mutual information IXY. It can also be determined, mutual information can be interpreted
Sir, Hx is basically the entropy of the source symbols, right?
yes, Hx is the entropy of the source symbol. Now, if we interpret in terms of the two conditional entropy with respect to, say, one is of x with respect to y, and another is y with respect to x. So then what happens? Then we will see that it will have this fashion. So what does that mean? That given we have x, and then what are the informations that y has obtained, and given that we have detected y, what are the information that x has obtained. So now there is an overlap. So this is the mutual information. The overlap has to be there. This is known as the mutual information. Now, we define another quantity which is known as channel capacity. So channel capacity again is depend on this mutual information. Mutual information as CS. Maximizing
ಇಲ್ಲ
IXY of the input probability P of Xi. Say for binary channels, We shall take some example next day about this thing, and then I think it will be better. Say for binary symmetric channels, channel capacity C would be IXY into PX0. And maximum of that, so that would be Px0 equal to Px1 equal to half. So that maximum of entropy will occur corresponding to that Px0 equal to Px1 for the equiprobable case, and because it is binary, that will be equal to half. So in terms of error probability, C would be equal to P log P plus 1 minus P log of 1 minus P plus 1. So we shall discuss about these things little bit further, taking one or two examples next day. The properties you have just written, the proofs are given in Hacking. If you want to go through that, you can go through it. Next, we will discuss about the basic of channel coding. So therefore, the increased detectability at the output corresponding to some input symbol is that we have to put certain number of bits such that this probability is improved further. So that means we have to add more information of the input symbols towards the output symbol, what is present. Suppose here we have only 0 and 1. So therefore, if we want to send 0, probably we want to add few more bits corresponding to that 0, such that if there is any error occur, that can be detected. So that philosophy we shall discuss next day.
Sir, could you please give some like written materials which we can separately read for this topic? Because some things like over here we're not able to understand like how we got those relations.
Which relation?
So some of these like equations about channel capacity and mutual information. It's like so if there's any we can get for this.
Okay, channel capacity. Yeah, channel capacity. Channel capacity is a definition that in terms of mutual information, okay, that it maximize which probability set will maximize the mutual information, that will give the channel capacity. So that means average mutual information, if it is maximized, so that is known as the channel capacity. In other way, in practical terms, suppose I want to transmit, say, 4 symbols in a channel with certain transition probabilities. So therefore, whether all these 4 symbols so the problem of maximizing mutual information means that we are how many bits we can allow to flow through this channel. So if it is maximum, then more number of bits can be flown through the channel. I think we will take some example, and then it will be clear that how this can be mutual information can be computed corresponding to various transition probabilities. So today probably you are tired, and let us stop here.